Hi, here's a circuit simulation and algorithm for the Nourish Pet robot meant to function in a swarm with the Super Pooper Scooper and the Play and Bark. So you'll see at the top I've defined variables and included this servo library. Here I'm defining just the motor pins to be integers, expect float for the distance and time to calculate for feet, and the triggers and echoes are assigned to these pins for the obstacle avoidance sensor. So the supplement delivery variables are going to just include one grind motor up here and the dog bowl sensor. So that whole loop of functioning depends on those two. Water dose variable is this sensor here, and then the food dose variable is this sensor here. So this block describes the obstacle avoidance block of code, just to assign that for checking distance. That'll be referenced later on. Here's the forward function. The upside to having gear motors is that I don't have to make one motor go counterclockwise and the other one go clockwise. I just only hook one wheel up to one of the axles on each side, and I can program each the same for the same voltages with digital write per each pin. So here are the forward ones, they match. Stop, they match, but there's no voltage applied. Vehicle left, one goes reverse, the other one goes forward, so that allows the robot to turn on a dime. Same with the right, but inverted. This grinder motor start is just going to be clockwise, and that's going to grind a pill up whenever it's ready, and then it's going to stop. Here's the setup functions for the obstacle avoidance, and here's the serial begin for any communication with other robots and the user. The supplement grinder setup functions are here to program those motor pins as outputs, and the nutrient delivery setup functions are here. So that all has to do with each of these sensors. So I've assigned one sensor to A5, one to A3, and one to A4. I believe this one is A5. Water dose is A3, and food dose is A4. So here with the loop, the obstacle distance variable will start with the check distance function earlier defined, and if that distance is less than or equal to 20, the vehicle is going to turn left. So this delay just allows a bit of time for the robot to not jerk around with all the payload, and while that if conditional is being sought, the obstacle distance has to be less than or equal to 20, and we're going to check distance during that time. Otherwise, the vehicle is going to move forward until it finds a dog bowl sensor, which is going to be a calibrated weight at, or until the sensor finds a dog bowl, which is going to be a calibrated rate at 1.865 pounds. And the food dose sensor is greater than 600, so that means that there's got to be enough food to deliver to the dog bowl, and the same for water. So the vehicle is going to stop. The servo here is going to open. It starts at 0 degree, or sorry, it's going to turn to 0 degrees, which is actually going to open the hatch, and then it's going to go back to 90 degrees, which is going to close the hatch after the grinder's done, and then all of the food and water for that daily delivery is used up. So here I'm going to start. You can see here that we have full water, full food, haven't found the dog bowl. The vehicle is going to move forward because it hasn't found an object within 20 inches. Now it's found an object. It's going to turn left until it doesn't find the object. And now it's going to look for the dog bowl. It's found the dog bowl. The hatch opens. The food and water leave. Supplement's delivered. That grinds the supplement. Now there's no more water, no more food. Hatch closes. Grinder stops. Now we're next to the dog bowl. It now turns away from the dog bowl until the user interrupts, turns it off, and it doesn't communicate with any other robots. Thank you.